Hello kids, welcome to ICSE Chemistry Hub. This would be my third video. Please do like and subscribe my channel to get the latest updates. Okay kids, so we are on the third part of electrolysis series and we had done the first electrolysis that was of lead bromide. So continuing with that series, today we will be starting with something called as electrochemical series. So as I told you, we had done the electrolysis of a compound called as PbBr2. What is the name of this compound? We know it is lead bromide. When lead bromide decomposes, we know it decomposes to give us Pb2 plus. And how many bromines are there? It is 2. So 2 bromide ions. As you can see in this equation, can you see in this equation, children? There is only one cation and there is only one anion. There is only one positively charged ion and there is only one negatively charged anion. One cation, one anion. But this won't be the same in all the cases. In many cases, you will have 2 or more cations, or you can also have 2 or more anions. So in some cases, when you do the electrolysis of some chemical compounds, there is a possibility that you might get 2 or more cations in it, in the same compound, and you may get 2 or more anions in it. So then who will decide that which one will get discharged first? Which one will be becoming neutral first? So this will be decided on a series which is called as the electrochemical series. Now I hope children, when we talk about electrochemical series, this series sounds very, very similar to what we call as the reactivity series of metals. Do you remember the reactivity series of metal? Yes, the reactivity series of metal looks something like this. I hope you remember the series. Okay, here also I'll give you a short form to remember it. Please stands for potassium. Cent stands for sodium. Cats, monkeys, and zebras into lovely hot countries signed General Penguin. So what is the sentence you have to remember, children? Please send cats, monkeys and zebras into lovely hot countries signed General Penguin. This electrochemical series for cation is the same as you have read for the reactivity series of metal. So can you tell me what is the sentence that you have to remember? Please. Here P stands for potassium. Cent stands for sodium. Cat stands for calcium. M stands for magnesium. A stands for aluminium. Z stands for zebra. I stands for iron. L stands for lead. Hot stands for hydrogen. Country sign stands for copper. Sign stands for silver. G stands for gold. And P stands for platinum. So this is the same series that you have learned for the reactivity series of metals. So when we study about the electrochemical series, we have something called as an electrochemical series for cations and we have something called as electrochemical series of anions. Now always remember, when we come to electrochemical series, please remember the sentence that I am telling you. The lower the position of the metal, the more easily will it get discharged. Am I clear to you, children? I am again repeating the sentence. The lower the position of the cation or the anion, the more lower it is placed, more easily, can you see? More easily will the discharge happen. For example, let's take a scenario where we have aluminium and where we have hydrogen. So if there is an aluminium and if there is a hydrogen, Which amongst the two would you think would get discharged? Please remember, the more lower the position of the metal or the cation in the electrochemical series, the more easily it will get discharged. Am I clear? Now, for example, if I take calcium and if I take lead, which one will you think will get discharged first? Yes, of course it will be lead. Why am I saying it will be lead? Because we know from this electrochemical series of cations, the more lower the position of the metal or the cation, the more easily it will get discharged. Clear? So, I have already done with the electrochemical series of cation. Can we start with the electrochemical series of anion? Now, for this also, when you have a look here, I will give you a short form to remember this. The short form is this. Suno, caliber, which stands for this too, I-O. What is the short form you have to remember, children? Suno, caliber, I-O. So what does this mean? Sun stands for sulfate, No stands for nitrate, Ca stands for chlorine, Br stands for bromine, I stands for iodine, and O stands for OH. So in this series also for anions, please remember, the more lower the position of the metal, of the anion in the electrochemical series, more easily will it get discharged. More lower the position, more easily it will get discharged. So if you have a chloride and if you have a hydroxide, children, can you tell me which one will get discharged first? Yes, it will be the hydroxide. Why? Because we know the more lower the position of the anion or the cation, the more easily it will get discharged. Please follow this arrow. The more lower the position, more ease of discharge happens. Clear? So in this electrochemical series, it is better to be down, because the more down you are, the more is your ability or the more is your capability, whether it is the cation or the anion, to get discharged. Okay. So this is what an electrochemical series is. Can we just read the PPT once? Electrochemical series is nothing but the ease with which the metal or the non-metal, when we say a non-metal, I mean the anion, can lose their electrons. When I say they want to lose, they want to get discharged. Clear? We have an electrochemical series for metal as well as we have an electrochemical series for anion. What is the sentence you have to remember for cation? Please send cats. Cats is calcium. Monkeys is magnesium. Ant stands for aluminium. Z stands for zebra. Into stands for iron. Lovely stands for lead. Hot stands for hydrogen. Country stands for copper. Science stands for silver, gold, and platinum. Clear? So more lower the position, more easily it will get discharged. Similarly for anions, what is the name you have to remember, children? Suno, caliber, I-O. S stands for sulfate, N stands for nitrate. What is nitrate? NO3, 1 minus. Caliber stands for Cl, Br stands for bromine, I stands for iodine, and IO stands for hydroxide. So this is the electrochemical series. One more thing that you need to remember while we are doing the electrolysis of the other compounds is whether the electrode, now what I mean by the electrode, children, the metallic plate that I have taken, the metal plates that I have taken, there are two types of electrodes that we can take. There is one called as an active electrode and there is one called as an inert electrode. What is an inert electrode? From the word itself, from the word inert, we mean it is that part of an electrode or it is that electrode which does not take part in an electrolytic reaction. Am I clear, children? So what is an inert electrode? This electrode does not take part in a chemical reaction. It has no part to play in the electrolytic reaction. Please remember the example as PIG. How will you remember all the metals? There are 3 inert electrodes. Remember the word PIG. P stands for platinum, I stands for iron, and G stands for graphite. Now please remember, graphite is nothing but, we can also call it as carbon. So what are inert electrodes, children? Inert electrodes are those electrodes from the word itself. They do not take part in a chemical reaction. And what is the short form you need to remember? Remember it by the word PIG. What does PIG mean? P stands for platinum, I stands for iron, G stands for graphite. Clear? We also have an electrode which is called as an active electrode. What is an active electrode? Again, look at the word. The word active means this electrode will itself start taking part in the electrolytic reaction. So it will not be just a mere spectator in the reaction. What is it going to do? It is going to take part in the chemical reaction. And what is the short form you have to remember for this? CNS. C stands for copper, N stands for nickel, and S stands for silver. So we have 2 types of plates that can be used while we are doing electrolysis. First one is called as an inert electrode. By the word inert means they do not take part. How will you remember the short form, children? Remember it as PIG. Platinum, iron, graphite. Graphite is nothing but carbon. So wherever you hear graphite or carbon, close your eyes and write that it's inert. What's the next type of electrode we have? The next type of electrode is active electrode. Now what are active electrodes, children? From the word itself. They themselves start taking part in the reaction. What is the short form you need to remember? We need to remember CNS. What does CNS stand for? Copper, nickel, and silver. So now, keeping all this in mind, we are going to start with the next electrolysis. It is the electrolysis of water. But can you see? Before water, there is a word written to it. What is the word written? We are not using the normal water, or we are not even using distilled water. Clear? You know the formula of water. What is the formula for water, children? It is H2O. Which type of bonding will happen in it? We know it is a covalent compound. Whenever there are 2 or more non-metals, we know it will be a covalent bonding. Clear? So we know covalent compounds are only and only made up of molecules. Now, can a molecule conduct electric current through it? If it wants to conduct electricity, what it should have? It should have ions. Do we have ions in water? No. We do not have ions because it is completely made up of molecule. So please remember, this distilled water or pure water is not a good conductor of electricity. It will not be able to conduct electricity. That is the reason why we are adding a word before it. What is the word we have added? We are using acidified water. Clear? Now what is the meaning of the word acidified water? We are adding just a few drops of any acid. We are adding a few drops. Let me put the word as we are adding any few drops of any dilute acid. Clear, children? And we are doing the electrolysis with the help of platinum electrodes. Can you tell me whether it is an active electrode or an inert electrode? This comes in PIG. Platinum is an inert electrode. So we are carrying out the electrolysis of water using inert electrode, which is the electrode we are using here. We are using platinum, which is an inert electrode. Now, can you see this apparatus here, children? It is called as the Hoffman's apparatus. What is the name of this apparatus, children? It's called as a Hoffman's apparatus. Okay. Just as I told you, pure water is not able to conduct electric current through it. Why? Because it is a covalent compound. When I say it is a covalent compound, what do I mean? It is made up of only and only molecules. But I need to pass electric current through it. Okay. So I will add a few drops of an acid. Now, which is the acid that is preferred here? Here we are adding a few drops. When I say few, just 1 or 2 drops of dilute sulfuric acid. This dilute sulfuric acid works like a catalyst. That is why we call this reaction also as a catalysis reaction. So in the board exam, if they ask you, what is the other name for electrolysis of acidified water? We can also call this reaction as a catalysis reaction. I hope this is clear to you. Okay. Now the next question that will be asked to you is, why are we preferring dilute sulfuric acid? Clear? Because the problem here is HCl and nitric acid are what type of acids, children? They are volatile acids. Especially nitric acid and hydrochloric acid. They are which type of acids? They are volatile acids. What do I mean by the word volatile acid? That means they vaporize off very, very quickly. So what is going to happen to them? The moment I put them into water, they might not even stay in that water. They will go off in the form of vapors. Clear? So remember this word, this term will be used many times in ICSE grade 10. So the word volatile means they will vaporize off very, very quickly. So that is the reason why we are not preferring nitric acid as well as hydrochloric acid. Okay. Can we go ahead with the electrolysis of acidified water? Now pay attention here, children. When I say electrolysis of acidified water, which is the first compound that will get decomposed? It is nothing but when I start the electric current, my water is going to get decomposed. It will decompose as H. What's the valency of hydrogen? We know it is 1 plus OH 1 minus. Am I clear till here, children? So water H2O is decomposing to give H1 plus and OH minus 1. This is how it will decompose. H plus OH minus. H plus is the cation, OH minus 1 is the anion. But is this the only thing I have added? No. Do you remember I have also added an acid? Which acid did I prefer here? I added sulfuric acid. Now how is this sulfuric acid going to break? How many atoms of hydrogen are there? As you can see here, it is 2H plus, which is the anion that I have in this acid. It is SO4. What is the valency, children? It is SO4 2 minus. So please remember, water will always decompose as H1 plus OH minus 1. Clear? H2SO4 will decompose as 2H. Can you see here? There's a 2 here. So 2H plus SO4 2 minus. So in my solution, I have a cation which is H1 plus and I have 2 anions. Which are the 2 anions? I have OH 1 minus and SO4 2 minus. This is what you can see here. There are 3 ions that are present in the solution. Which are the 3 ions, children? I have H plus and I have OH minus here, which is hydroxide, and I have SO4 2 minus here. Clear? Okay. Now we will start with the reaction at the cathode. Now what is the cathode here, children? Cathode is nothing but the negatively charged ion. Clear? And we know it is always C2C. What's the meaning of the word C2C? Cations. What are cations? The positively charged ions will run and go towards the cathode. Opposites attract. So where will the cations go, children? The cations will run and go towards the cathode. So which is the cation I have? Whether it is H1 plus, 2H1 plus, both are the same. So which is the only cation available here? It is H1 plus. Okay. I had told you in my previous electrolysis, if it is a plus here, close your eyes and put a plus here. How many electrons? 1 electron. So H1 plus, here also I will put a plus, it becomes 1 electron. what will I get? It will become neutral. When I say it become neutral, it means it does not have any charge on it. So what does it become, children? It becomes a neutral hydrogen atom. But is this neutral hydrogen atom stable? No. It is highly unstable. So what does it do, children? The moment it forms an H, I know my H is unstable. So it will immediately combine with another H and it will form H2 gas. Clear? So what will be released at the cathode? Please remember, hydrogen gas will be released. Please remember this. Or my cathode, which gas will be released? My hydrogen gas will be released at the cathode. This is exactly what you can see here. At the cathode, what is going to come? The cations. Clear? So H plus, if it is a plus here, it has to be plus here, plus 1 H. It will give me H. Clear? It will become a neutral hydrogen atom. But my H is highly unstable. So what will it do? It will immediately combine with another H and it will form H2, which is my hydrogen gas. So please remember which gas will be released at my cathode. At my cathode, I will always get hydrogen gas. Clear? Okay, next. I am starting with the reaction at the anode. What is the reaction at the anode? Anode is positively charged. So of course, my negatively charged anions or ions will start running towards the anode. But here can you see there is a competition. There is a competition between OH minus 1 and SO4 2 minus. Both will run, but only one of them will get discharged. Now who will decide this? This will be decided by the electrochemical series of metal. Do you remember the electrochemical series of anions? Sunno, caliber, IO. So can you tell me which one will be discharged here? Of course, it will be the hydroxide. I have sulfate as well as I have sulfate as well as I have hydroxide. But which one will be discharged here? It will be OH minus 1. Why? Because of the simple fact that it is lower in the electrochemical series. If it is a minus here, put a minus here. How many electron? 1 electron. So it will give me OH. Clear? OH minus 1. If it's a minus here, close your eyes and put a minus here also. What is the number here? 1. So I will also put a 1 here. It will become OH. Clear? Now again, OH is highly unstable. So it will combine with another OH. And what will it give me? It will give me OH. What is a compound? H2O plus O. Isn't it, children? OH minus 1 electron, I will get OH. Clear? Now we know OH is highly unstable. So OH will again combine with another OH. This OH will combine with one H here and it will give me H2O plus O. Now what is the problem again here? O is highly unstable. So it will immediately combine with another O and it will give me O2. Am I clear, children? So which gas will be released at the anode? Please remember, oxygen gas will be released at the anode. Clear, children? Okay. So I am telling you the equation once again. At the cathode, I know always it is C to C. That is H plus. If it's a plus here, plus 1 electron, it will give me H. Clear? Now I know H is highly unstable. So one H will combine with another H to form H2. Please keep writing and practicing this equation. So which gas will be released at the cathode? It will be my hydrogen gas. Clear? Now when we go to the anode, what happens at the anode, children? We know the anode is, yes, it is positively charged. So it will be A to A. Clear? So here I have a competition between two ions. I have OH minus 1 and I have SO4 2 minus. Which one will get discharged? So no, we know S is at the top, caliber IO. OH is at the end. Clear? So how will I go there? Which one will get discharged? Of course, I know it will be OH minus 1 because it is lower. If it is a minus here, it will be minus here also. So which ion will I get? OH. We know OH is highly unstable. So what is it going to do? It is going to combine with another OH and it will combine like this. If there are two H's and one O, it will give me H2O plus O. Clear? Now O is again unstable. So what will it do? It will combine with another O and it will form O2. So at my anode, which gas will be released? Oxygen gas will be released. Clear? Now always in electrolysis, if you are balancing the chemical equation, you need to do it from the back. Am I clear, children? So I will start whenever I'm doing a balancing of an electrolysis reaction. I will always start from the back. Clear? So how many oxygen atoms do I have here? I have 2. What about here? I just have 1. So I need to make it 2. How can I make it 2, children? I will multiply the whole equation with 2. Did you understand this? I have O2 here. If I need to balance the equation, if I need to make this 2, what do I need to do, children? I need to balance the whole equation with 2. Yes or no? So 2OH, 2OH, 2H2O plus it will give me 2. Clear? Now how many OHs are here? 2 here, 2 here. So this is 2 plus 2. Can you see the 2 here, children? 2OH, 2OH, it becomes 4. So I need to make this as 4OH. But can I just multiply this? No. I again need to multiply the whole equation with 4. Why am I doing this? So that I can balance the equation. So I'm multiplying the whole equation. 4 here, 4 electron, and here it becomes 4. Clear? Now there is a rule in Arrhenius equation which says that the number of electrons at the cathode and at the anode should be the same. At the anode, how many electrons do we have? We have 4 electrons. Can it happen that at the cathode it can only have 1 electron? No. So we need to balance this equation. I am making everything 4 here. Yes or no? So 4H, 4 electron, instead of writing it as 4H, what did I write it as? 2 here, 2 here. 2 into 2 becomes 4. This is clear? So how many volume of hydrogen gas is collected? 2 volumes of hydrogen. How many volume of oxygen is collected? Just 1 volume. This is how you get the volumes, children. To you, please write and practice these equations. If you had liked this explanation of mine, please do like and subscribe my channel. Keep learning, keep writing, keep revising. Thanks a lot.